Hello everyone, welcome to PE Academy. In this video we are going to be looking at indices. We are going to be looking at the laws of indices and solving different questions under indices. So at the end of this video you'll be able to solve just any question that has to do with indices. So if you are new to this channel, kindly click on the subscribe button and the little bell button beside the subscribe so that you get notified when next we release any video. So without wasting time, let's get into the video. So right here are the laws of indices. There are eight of them listed here. You might find some in some material, you might find them less, you can find them more, but right here are 8. So we are going to be looking at them one after the other. The first law we have here is a raised to power y times a raised to power z is same thing as a raised to power y plus z. So what it means that if this a is the same number and the power are different, we can equally add up the power. So let's look at it from using this example. Let's say we have a raised to power 3 times a raised to power 2. So you can, since we have a and a, you can say a raised to power 3 plus 2, that is equals to a raised to power 5. So let us check. So a raised to power 3 is a times a times a, then times a raised to power 2 is a times a. So if you are to add, to do this, that is equals to a raised to power 5. 1, 2, 3, 4, 5, a raised to power 5. So now let's use real numbers. Using real numbers. So let's say we have 3 raised to power 2 times 3 raised to power 3. Now we can write this as, this is same thing as 3 raised to power 2 plus 3. That's giving us 3 raised to power 5. And which is equals to 243. Now if you are to looking at it like this, 3 raised to power 3 is 9 times 3 raised to power 3 is 27. So 9 times 27 is same thing as 243. So you can see that is it on the first law. If you have the same number and they have different power, you can just pick one of it like it here and add up the power. So that's what this example is talking about. That is it for the law 1. So now let's go to the law 2. Now for law 2, if we have a raised to power y divided by a raised to power z, we can rewrite it as equals to a raised to power y minus z. So let's look at it from here. So let's say we have, now this is for law 2. So let's say we have a raised to power 5 divided by a raised to power 2. So we can write this as a raised to power 5 minus 2, which is equals to a raised to power 3. So now let's use let's just check it to see if we are right. So a raised to power 5 is a in 5 places. So if we have a times a times a times a times a over a raised to power 2, that's a in 2 places, that will be a times a. From these two, this can cancel out this can cancel out this. So now we are left with 1, 2, 3 with 3a. That is equals to a raised to power 3. So you can see that we are correct. Now let's use real numbers. Using real numbers, so let's 3 raised to power 5 divided by 3 raised to power 2. Since they are both the same number, 3, 3, we can write it as the same thing as 3 raised to power 5 minus 2, which is equals to 3 raised to power 3 raised to power 3. That's 27. So now let's check it. So now 3 raised to power 5 is same thing as 3 times 3 times 3 times 3 times 3 over 3 times 3. So these two can cancel out this. So we are left with 3 times 3 times 3, which is equals to 27. So that is it for law 2. So law 2, so a raised to power y divided by a raised to power z is same thing as a raised to power y minus z, provided by this a is same numbers. So let's go to law 3. Law 3 is, if we have a raised to power y into brackets raised to power z, is the same thing as a raised to power y times z. So what this means is this. So law 3, so law 3, you can also rewrite this as, if we have a raised to power 2 in brackets raised to power 3. So it's the same thing as having a raised to power 2 times 3, which is equals to a raised to power 6. So what this, let's check if we are correct. Just to check, a raised to power 2 raised to power 3, that means a raised to power 2 in 3 places. That means a raised to power 2 times a raised to power 2 times a raised to power 2. Now this is what this means. A raised to power 2 raised to power 3. That's a raised to power 2 in 3 places. So if you are to open the bracket, we have a times a times a times a times a times a. So if we should open it, then we have a raised to power 6, because right now we're having 1, 2, 3, 4, 5, 6 a's. So let's solve it using real numbers. So using real numbers, if we have 2 raised to power 2 into brackets raised to power 3. So what it will give us is 2 raised to power 2 times 3. That is equals to 2 raised to power 6, and that will give us 64. So that is it for law 3. So now let's go to law 4. Now law 4 is a over b into brackets raised to power y. So if you have a over b raised to power y, it's the same thing as a raised to power y over b raised to power y. What is this? This a will have the power of y, and this b will have the power of y when we remove the brackets. So we can rewrite it as, so the same thing as if you're having a situation like this where you have 2 over 3. Okay, you're not seeing it. So this is law 5. So the same thing as having a situation where you have 2 over 3 raised to power 2. So you can rewrite this as 2 raised to power 2 over 3 raised to power 2. So if you have to simplify this, 2 raised to power 2 is 4, 3 raised to power 2 is 9. So another example is where you have 1 over 3 raised to power 3. So it's the same thing as having 1 raised to power 3 over 3 raised to power 3. So which is equals to 1 over 27. 3 raised to power 3 is 27. So that is it for law 5. So now let's go to law 6. Law 6 is, if you have a raised to power z over y, it is the same thing as having this y, the one at the denominator, outside the square root of the number, all in brackets z, the z which is the numerator. So let me use real numbers as an example. So law 6. So if you have, this is, so let's say let's use real numbers now. So if we have 8 raised to power, so 8 raised to power 2 over 3. So you can rewrite this as, since we have 3 here, as cube root of 8 all raised to power 2. Look at it here. Cube root of 8 raised to power 2. Let's compare it with log 6. So if you have to compare this with the law, you see that this the A here is the same thing as the 6. The Z here is the same thing as the 2, and the Y is the same thing as the 3, and the Y is equals to 3. So that's how you can write it as cube root of 8 all raised to power 2. So if you are to simplify this further, we'll have cube root of 8 is 2 raised to power 2, giving us 4. So let's look at another example using that log 6. So if you have 9 raised to power 1 over 2, so you can simply rewrite it as square root of 9 all raised to power 1. Square root of 9 raised to power 1. So if you have to simplify it, the square root of 9 is 3. That will be 3 raised to power 1. 3 raised to power 1 is the same thing as 3. So that is it for log 6. So let's go to log 7. Log 7 here says a raised to power 0 is equals to 1. And what it means is that any number raised to power 0 is equals to 1. So if you have whatever the number is, if it is 2 raised to power 0, it's same thing as 1. If it is 1000 raised to power 0, it is 1. This is log 7. So if it's whatever it is, once it is raised to power of 0, it is 1. So that is it for log 7. So for log 8, if you have log 8 here, it says a raised to power minus 1 is equals to 1 over a. What's this saying? That means if you have 3 raised to power minus 1, now you can write it as 1 over 3 raised to power 1. The minus will no longer be there. So the minus will no longer be there. Since we have raised to power minus 1, you can just write it as 1 over 3. So, and even if it is 3 raised to power minus 2, so it's the same thing as writing 1 over 3 raised to power 2. So giving us 1 over 9. So when you have a power that is negative, you just write equals to 1 over that same value without the negative. So you can also have it as either 3 raised to power minus 4, then is equivalent to 1 over 3 raised to power 4. So that is it for on the laws of indices. So right here I've been able to break down these 8 laws that I have here. So if you have any question, please leave it in the comment section below. In the next video we are going to be solving real examples, more examples using all these laws, and we are going to in each example we might be using 1 or 2 laws to solve different questions under indices. So make sure you subscribe to this channel, and you'll find the link to the other part of this video in the description below. Thank you.